For number 50, they give us that a sequence of terms is defined by the first term, a sub 1 is 1, and the subsequent terms are given by 5 minus n times a sub n minus 1, which is the previous one. And then they want us to calculate this total sum. So let's go ahead and expand these. So a1 is given by 1. A sub n, so a sub 2 is going to be given by 5 minus n, so 5 minus 2, times a sub n minus 1. So since we're a2, it's going to be times a sub 1, which is 1, and that's going to be 5 minus 2 is 3 times 1, 3. So a sub 3 is going to be given by 5 minus 3, so 5 minus 3, times a sub n minus 1, so times a sub 2, which in this case is the previous one, number 3. So we're going to get 5 minus 3 is 2, times 3 is 6. Now a sub 4, we're going to have 5 minus 4 times a sub 3, so times the previous one, which is 6. In this case, 5 minus 4 is 1 times 6 is going to be 6. And then we have a sub 5, which is 5 minus 5 times the previous one. So the previous one is the value of 6. And if we do this, we get 0 times 6, which is equal to 0. And then a sub 6 is going to be 5 minus 6 times the previous one, which is 0. So that's going to be minus 1 times 0 is 0. And then a sub 7 is also going to be 0, because no matter what's within this bracket, this 5 minus n, remember that we're always going to multiply by the previous one, a sub n minus 1. And the previous one is also 0, and then which results in 0, and then a sub 8 is going to be something multiplied by the previous one, which is also 0, and so on and so forth. So we can see that after, when we begin at a sub 5, all the terms at a sub 5 and beyond are actually equal to 0. So the sum of all terms, so from n is equal to 1 to infinity of a sub n, that's just going to be the first one, so a sub 1, which is 1, plus a sub 2, which is 3, plus a sub 3, which is 6, plus a sub 4, which is 6, and then plus an infinite string of zeros, right? And so if we calculate this, that's going to be 1 plus 3, which is 4. 4 plus 6 is 10, plus 6 is 16. So this 16 is the total value of this sum here.